Welcome to Spring LIB.
So for part A, we just want to find the work done, and then for part B, we want to find the initial velocity. So for part A, the work done is going to be equal to the integral from 0 meters to 5 meters of the net force. So it would be the net force would be equal to the force of gravity minus 640x cubed, again, times dx. So this would equal mgx minus 160x to the fourth, and then evaluated at 0 and at 5. So that means that the work would be equal to 75 kilograms times 9.8 meters per second squared times 5 meters minus 160 times 5 meters quantity to the fourth. And we find that the work here, the work needed is, rather the work done is going to be negative 9.625 times 10 to the fourth joules. So essentially, this is the negative work being done. We can, for part B, relate this to the change in kinetic energy. We know that the change in kinetic energy is going to be equal to 1/2 m times velocity final squared minus velocity initial squared. We know that the final velocity is 0. Therefore, we're trying to find the initial velocity, and we can say that the initial velocity equals negative 2w divided by m divided by, rather, to the 1/2 power. So this will be negative 2 times negative 9.625 times 10 to the fourth. And this will be divided by the mass of 75 kilograms, all to the 1/2 power. And this is giving us approximately 51 meters per second. So this would be the initial velocity, and this would be the total work done from 0 meters to 5 meters. That is the end of the solution. Thank you for watching.